We're going to have a look at solving quadratic and rational inequalities. I'm going to start off with this quadratic trinomial inequality here. It's x squared plus x minus 12 greater than 0. And x here is going to be an element of, or x is going to be a real number. So when solving these inequalities, you're going to end up here with a range of values for x, rather than with an equation you usually end up with two values for x for quadratics. But here we're going to end up with a range of values. So let's have a look at the procedure here. So what we're going to do first is, it's already in its basic quadratic trinomial form, so we don't have to do any manipulation of this particular inequality. So what we're going to do here is just first of all find the roots. If x squared plus x minus 12 was equal to 0, what would the roots be? In other words, we want to draw a little sketch over here of this quadratic equation here. So we want to know where this actually cuts the x-axis. So what we're going to do here is just factorize it first. So we take this x here is going to be x times, this x squared is x times x. 12 here, that's going to be 12 times 1, 2 times 6, 3 times 4. Well, the pair that are going to work there, that's going to be 4 times 3. So 4 times 3 will work. Now we need a minus 12 here, so it's going to be plus times minus, or minus times plus. So I know the plus is going to be here and the minus is going to be here. Okay, so that will give me x plus 4 equal to 0, or x minus 3 equal to 0. And then here we've got x is equal to minus 4, or x is equal to 3. So if I was to draw a sketch of this this equation here, or this quadratic here, what I would get is something like this. This would be minus 3 here, and let's say this is 4 here, and the graph would look something like this. Okay, now we weren't asked to solve the equation, we were asked to solve this original inequality here. And if you look at this inequality here, what we're looking for is we're looking for the range of values of x that, you know, such that when we put them into this here, we will get y values greater than 0. So this here really is just y, if you like. This is y here. So what we were looking for is y greater than 0, y greater than 0. So this line here, this curve here, is made up of an infinite number of points, and each point has an x value and a y value, but we're only interested in the points where y is greater than 0. So we're looking at this part of the y-axis here, so we're looking at these points down along here. So really what we're doing is we're looking at this part of the graph here. All of these points along here and all of these points up along here will have positive y values, will have y greater than 0. Now we don't want to include the points on the x-axis, because remember y has to be greater than 0, not equal to 0. So usually what we do is we put a little circle around that point there, a circle around this point here, and we don't fill in the circle because we don't want to include 4, we don't want to include minus 3. So our solution then, our final solution for this particular quadratic inequality here will be, so our answer here, if you like, will be these x values down along here and these x values up along here. These x values will give us, those particular x values will give us all of these positive y values. So this x value here, for example, will give me this positive y value. This x value here will give me this positive y value here. These values in here, for example, if I was to pick let's say this x value here, I would come down to the graph, go across, I would end up with a negative y value, a y value less than 0, and that's not what we require. So we don't need these x values in here, we need these x values out here. So our final answer then will be x will have to be down along here, so in other words less than minus 3 and greater than 4. So we need these x values up here bigger than 4. So this is really our solution here to this particular inequality. Okay, so let's move on and have a look at another one. We'll have a look at a rational inequality, and we'll try to solve that. We'll effectively end up with a quadratic inequality again, but we just got to do a little bit of work beforehand. So the one I'm going to have a look at is this one here, 2x minus 5 divided by x minus 3, and we'll say that's less than or equal to 5 over 2. X is going to be an element of OR again. And also we can see here that x can't be 3. X cannot be equal to 3 here, because if x was 3 here, we'd end up with 0 on the bottom of this fraction here. You can't divide by 0, so we can't have x equal to 3. So this inequality, or this fraction, would be undefined at x is equal to 3. So let's just work our way through this. So what we've got to do first is try and manipulate this inequality so that we end up with something we can use, something that will look like what we did in the first example, a quadratic inequality. Now what we're going to have to do is get rid of these denominators, get rid of the fractions first. So what we're going to have to do is multiply across by x minus 3 times 2. Now the problem with that is we know that 2 is positive, but we don't know if x minus 3 is positive. X could be, 1, or it could be minus 5, or it could be minus 10. We don't know what x could be, so we don't know whether we're going to be multiplying across here by a positive or negative value if we multiply across by x minus 3. So to ensure that we're multiplying across by a positive number, what we do is multiply across by x minus 3 squared. Because remember, if we multiply across by x minus 3 and x minus 3 were negative, then we would have to flip around this inequality sign to greater than or equal to. So to ensure that what we're multiplying across by is positive, what we're going to do is multiply across by x minus 3 squared and the 2 as well. So this is what we're going to do. Just write it out here. So we've got our 2x minus 5 divided by x minus 3, and then on this side we've got our 5 over 2. So I'll just put in what we're multiplying across by. We're going to multiply across by 2 anyway, and then x minus 3 squared. And that's all over 1 if you like. And we do the same over here. So we're multiplying across by 2 times x minus 3 squared over 1. So why do we do that? Well, we do it because it works, I guess. We'll get rid of these numbers on the bottom here, these denominators. So let's have a look. We'll end up with this 2 on the top anyway, and then this x minus 3 here will divide into one of these x minus 3's here, and we'll be left with 1x minus 3 here. We'll be left with one of these x minus 3's on top here. Because remember, x minus 3 squared is x minus 3 times x minus 3, so this will divide into one of those x minus 3's, and we'll be left with the other one. And then we're left with 2x minus. On this side then we're left with, well, this 2 here will divide into this 2 here, so that will just become 1. So we'll end up with 5 times x minus 3 squared. So you can see here we've ended up with an inequality here, but we've gotten rid of these denominators. We've no more fractions here. Okay, so let's continue on. So we got to multiply everything out. So I'm going to multiply the first bit out first. Let's see, this 2 times x, 2 times 3 here. So we end up with 2x minus 6 here, and here we end up with 2x minus 5. On this side we end up with 5, and we got to multiply out this here, x minus 3 times x minus 3. Well, that's going to be x squared minus 6x plus 9. Okay, so let's multiply this out then. We've got 2x times 2x, that's 4x squared. We've got the 2x minus 5, that's minus 10x. We've got 2x times minus 6, so that's minus 12x. And then we've got the minus 6 times minus 5, that's plus 5 6 is 30. Okay, on this side then we just multiply out by the 5 here, so we got 5x squared minus 30x plus 5 nines 45. Okay, so let's simplify this whole thing. Now I've got an x squared here, I've got an x squared on this side. This is a 5x squared, this is a 4x squared. So let's keep everything positive. So I'm going to put the 0 on this side. I'm going to bring everything else over to the other side. So 5x squared minus the 4x squared, it's just going to be x squared. So I'm subtracting 4x squared from both sides. So really all I'm doing is putting in a minus 4x squared here and a minus 4x squared here. That'll disappear here. Now here I've got a minus 10x minus 12x. That's minus 22x. So what I'm going to do here is add 22x to both sides. So I'm going to add 22x to this side, so that'll get rid of all of this, and on the right hand side then I'll just end up with minus 8x. So I got minus 30x plus 22x, that's minus 8x. So I got this plus 30 here, so I'm going to put in a minus 30 to get rid of it, and a minus 30 over here as well. So that will just leave me with 45 minus 30, so that's just plus 15. So you can see here now we've ended up with this quadratic trinomial inequality here, so we've got to solve that. So the first thing I'm going to do is x squared minus 8x plus 15 equal to 0, so to find the roots. So I should be able to do that easily enough. So I've got an x times an x here. I've got 15 here, so that can be 15 times 1 or 3 times 5. It's going to be 3 times 5. So I'll do 5 times 3 here. It has to be plus 15, so it has to be minus minus or plus plus. Because I've got a minus here, I'm going to put in minus and minus here. And that works for me. So I just end up with x is equal to 5 or x is equal to 3. So what that will look like is something like this. That's supposed to be a y-axis, supposed to be straight. So what I end up with is something like, something like this. Okay. Let me do that a little bit better. Okay, a little bit better. Now, so we know that this here is going to be 5 out here, and this is going to be 3 here. So what do we actually have to solve? Well, we have to solve this thing here. This is the same as our original inequality. That's exactly the same as this thing here, which is what we have. This thing here actually, which is what we have to solve. We just have manipulated the letters and numbers. So we have this here that we got to solve. So what do we actually have to do here? Well, what we have to do here is solve for, this is y here, remember, so that's y on that side, greater than or equal to 0. So we want y to be greater than or equal to 0. Now, y being greater than or equal to 0 means, again, we're looking at this part of the graph up here. These points here all have y values, y coordinates that are positive, greater than or equal to 0. We have to include the 5 here, and we're looking at these values up here as well. Okay. Now, do we include the 3 and the 5 is the next question. Well, if we go back to our original inequality here, we had to solve this, x is an element of r, but x is not equal to 3. X cannot be equal to 3 here, because we'd end up with a 0 on as the denominator of this fraction. You can't divide by 0. You can't have 0 on the bottom of a fraction. So x cannot be equal to 3. So what we got to do here is put a circle around this 3 here, because we don't want x to be equal to 3. But x can be equal to 5, so we're going to put a dot there, and we're going to fill it in. Now what x values then will give us this part of the graph here, these positive y values? Well, we're looking at these x values out here again, same as the previous example, these ones out here. So again, all of these x values will give us positive y values, this part of our y-axis here. We'll end up on the positive part of our y-axis here. So again, if we picked a point here, for example, we'd end up getting a negative y value, and we don't want y to be less than 0, we want y to be greater than 0. So our solution in this case is just simply x will be less than 3, remember, and greater than, or it can be equal to 5. So that's our range of x values that will that's the solution for this particular inequality. Okay, and that's it for quadratic and rational inequalities.